Yes, ma'am.
Okay. This. So the first question that we have is from worksheet 1.1. Okay. So it says determine the general solution of each of the following differential equation. And then they are saying give the answer in its simplest explicit form. So if we look at this differential equation, you can see that it is in the form dy dx is equals to say f of x, where f of x is this given function. And then remember, if we have something like this, we just directly integrate. So if we integrate, we will have y, and on the right hand side, that will be the integral of x over x squared plus 1 dx. So now we need to integrate x over x squared plus 1. So we will use the u substitution, that is u is equals to x squared plus 1, and then du is equals to 2x, okay, 2x dx. And then from there, if we now substitute that and write this integral in terms of u, we will have 1 over 2 times 1 over u du. And then from there, we can now integrate. So I'll just put the integral sign there, and then we still have the y on the left-hand side. So now if we integrate, we will get 1 over 2 ln of u plus c. So we just need to now substitute back the u. So the u is what? It is x squared plus 1. So we will have 1 over 2 ln of x squared plus 1 plus c. Okay, so this will be the explicit solution of this differential equation. Do we all understand? Any question? Can you guys hear me?
Of course, we can.
Yes,
Okay. Do we all understand this exercise?
Yes.
Okay, I'm assuming that you do understand. But then, guys, if there's something that you don't understand, please do stop me and let me know, okay? And then, yeah, then at least that way we'll be able to address the things that you guys don't understand. So this is the second differential equation from this equation. So what you're going to do for the next 5 differential equations, we will be solving the general solutions, okay? And then we will try to write the answer in an explicit form. So the next differential equation that we have e to the power t times di over dt, and then they are saying that is equals to 4. So when you have a differential equation of this form, the first thing is to write that in the standard form. And if we write this in standard form, we will have what? We will have di over dt is equals to e to the power 2t times 4. Okay, so now that we have this equation, and then you can see it is in the form di over dt over f of, so in this case it will be f of t. So f of t being this equation. So in this case, you can just directly integrate. So if we integrate, we will have what? I, and then here we'll have the integral of 4 e to the power 2t d dt. Okay, and then we integrate.
Sorry to interject.
Yes.
Are you sharing your screen?
Yes, I'm sharing my screen. Can you guys see my screen?
Yes.
Yes.
Yes, I'm sharing my screen.
Okay.
I think the only thing, let me just go back. I think I just forgot to start that. I need to start the record. I just need to start. Okay, who's recording? Okay, never mind. Let's just get it on. We will see.
Uzonyanyisa phakathi.
Can you guys hear me?
Yes,
ma'am, we can hear you.
Can you guys see my screen?
Yeah, it's still loading.
Yes, ma'am.
Yes, we can see your screen now.
Okay, thank you. Okay, so let's do that. So we were still here trying to solve this integral. So now we have to integrate e to the power 2t. Okay. So if you can get the formula sheet, I think we will use rule number 4. Rule number 4 will help us integrate this. So if we integrate this, we will get what? We will get 2e to the power 2t, right? That will be I plus c. So that will be the general solution to this differential equation. Any question?
Excuse me, ma'am.
Yes.
What happened to the negative 2t?
Negative 2t. Remember, we are saying that we need to write this in standard form, right? So if we're to write in standard form, we have to write it in this form, okay? So on one side, we have to just have di dt. So we have that, meaning that we just have to divide throughout by e to the power 2t. So if you were to divide 4 over e to the power negative 2t and simplify, you will get this. Do you understand?
Oh, I get it. Thanks, ma'am.
Okay, great. So this is the general solution to this differential equation. So now let's move on to the next one. Any questions before we can move to the next one? Okay, no questions. So the next one we have dx dt is equals to t plus 1 over t minus 1. So if you can look at this integrand there, you will see that we first have to apply or use the long division, okay? Because you can see that the degree of this polynomial is what? It is equal to that of the denominator. So we first have to do what? We first have to use long division. So from the long division, remember in this case, and this is the division sign. So here you will write the divisor, which is in this case, it is t minus 1. And then here you will write the dividend. So that will be t plus 1. So what you do next is you take this and divide it here. So you will have t divided by t. And then that is just 1. So you now take this one and multiply each term of the divisor. So in this case, that will be, you say 1 times t, 1 times negative 1. So in this case, if we do that, we will have t and then we'll have negative 1. So once you multiply this with every term of the divisor, you will get to this point. So now what you just need to do is to subtract. So what you just need to do is you now say t minus t, that will be 0. And then now you say t minus minus 1. If you say t minus minus 1, that will give you a positive 2. And then in this case, we will stop here. We will stop here. And then it will mean that, and then that means that 2 is the remainder. So now this is the same as dx dt is the same as 1. So this is the 1 there plus the remainder there. So 2 over, then you write the divisor there. So now we have this. So now we just need to what? We just need to directly integrate. So on the left-hand side, if we integrate, we will get this. On the right-hand side, we will get what? It would be the integral of 1 plus 2 over t minus 1 dt. Okay, so guys, don't just say the integral of 1 plus 2 over t minus 1 dt, because then it will mean if someone comes, he will think that this only applies here. So please make sure that you use the bracket, okay? So the next thing is to integrate. So if we integrate 1 with respect to t, we will get what? We will get t. And then if we integrate 2 over t minus 1, we will get what? We will get 2 ln of t minus 1. Okay, and then remember, don't forget to write the constant of integration. So that's what we have there. So now our solution is, the general solution in this case, it is x of t is equals to t plus 2 ln of t minus 1 plus c. Okay. So that is the general solution. Do we all understand? Any question? Yes?
Yes, ma'am. I wanted to ask, what if we separate the fraction and make it like t divided by t minus 1 plus 1 over t minus 1? Would it work, or would the solution be different?
It will work. This is 1 over t, and then you do that. This is mathematically correct. It will work. Okay. That's another approach. Okay.
Okay.
So now let's move on to the next one. This is 1.3, something there. Okay, so in 1.4, we have got a differential equation, and then it says dy dx is equals to what? Is equals to, I'm just trying to use this, is equals to sine 5x and what? Sine x. So now we just need to do what? We just need to solve this. How are we going to solve this? Anyone? Anyone? How are we going to solve this?
Use rule number 44.
We are going to use rule number 44. Okay. So from the formula sheet there, if you can check your integration and trig formulas, you can see in rule number 44. In rule number 44, this is, let me just write it down. It is sine A times sine B is equals to 1 over 2 into cos of A minus B minus cos of A plus B. So that is rule number 44. So of course, in this case, we are going to use this rule. So in this case, if we use that, we will have dy dx. We will have, so in this case, it will be what? It will be 1 over 2 cos of that will be 5x minus x, right? So that will be 4x, and then minus, so that will be 5x plus x, that will be 6x. So we now have cos of 6x. Okay, so now we just need to integrate. So if we directly integrate, we will get y, and then here we will have what? The integral of what we have here. So that will just be half into cos 4x minus cos 6x, okay, dx. So now we just need to integrate. So what will be the integral of cos 4x? Anyone? So if you can check your formula sheet, of course, that will be rule number 9, but then I'm sure by now we all know the integral, of course, okay? So what is the integral of cos 4x? Anyone? I'm listening, guys. Can you guys hear me?
I think it would be
Or
like sine 4x divided by 4.
it will be 1 over 4 times sine 4x. And then for the second one, it will be 1 over 6 times sine 6. Okay, let's do that. So that will be 1 over 6 times sine 6. Sine 6x, okay? And then don't forget to write the constant, the integration constant thing. So what we just need to do is to now just simplify, okay? So if we simplify, we will get 1 over 8 sine 4x minus 1 over 8 sine 6x plus c. So that is the general solution to this differential equation. Any questions before we move on to the next exercise?
Ma'am, isn't it 1 over 12 sine 6x?
1 over 12. 2 times 6 is 12. That will be 1 over 12. Do we all understand? Okay. I put it as a yes. So now let's move on to the next exercise. Yes. I can see you guys are raising are raising hands. I'm only using one device, so I don't know. I cannot see who's raising up their hands or who's not doing what. So if you have something to say, just unmute and say it. Okay. Unmute your mic and say the question. Any question? Okay, I'll move on then. Okay, so we're looking at another differential equation. Remember, the question was determine the general solution and then try to also express the solution in explicit form. So in this case, you can see we have what we have a dot notation. And then remember, with dot notation, we know that is just differentiation with respect to p. So in this case, this is the same as dp over dt is equals to 1 over 2 cot squared of what 2t. So the dot notation just means differentiation with respect to t. So now that we have this, in this case, you can see that we just need to directly integrate. But then now the question is, can we integrate cot squared 2t? Anyone? So in this case, we will use rule number 14. No, 40. Rule number, which one is it? Yes, rule number 40. Okay, so if we use rule number 40, let me just write rule number 40 here. It says 1 plus cot squared. Yes,
Which
I'm listening.
worksheet are they doing here?
I don't know.
Cos x squared x. Is there a question? Yes, I'm listening. Is there a question? Okay, no question, we'll continue. So I was saying for this expression here, we will have to use rule number 40, and rule number 40 is like this. So now we are just going to rewrite cot in terms of cosec. Okay, so in this case, we will have what? We will have 1 over 2 into cosec squared over 2t minus 1. This is just from this rule. This is rule number 40. Okay, and then from there, what you just need to do, we just need to directly integrate. So in this case, you have p here, and then here I can just put in the what do you call it? The integral sign. Let me just put it there. Okay, so we have dt. So now we're just going to integrate. So we have p there, we have 1 over 2 then. So what is the integral of cos x squared of 2t? Anyone?
Rule number 16, it's going to be negative cot.
Thank you
Negative
so
cot
much.
2t over 2.
Is going to be, of course, rule number 16. So if we use rule number 16, we're going to be negative what? 1 over 2 cot, and no, cot, not cos, cot of 2t minus the integral of 1 dt. It is what it is, just t. So we will do that, and then now we add the constant of integration. Okay, and then from there what we just need to do is to just simplify. So if we simplify, in this case we will have minus 1 over 4 cot of 2t minus that'll be t over 2 plus c. So this is the general solution to this differential equation. Any question? Okay, if there are no questions, I will move on to the next exercise. Okay. This is okay. So in the next exercise, or the exercise that I have on the screen there, they are saying determine the particular solution of the following boundary value problem. Okay, so in this case, we've got this differential equation, and then we've got this a boundary condition. Okay, hence they are saying it is a boundary value problem. So the first thing is to actually write this in standard form. So if we do that, we will have what? dv dt is equals to what? Is equals to minus t plus 1. Okay, so now we just need to integrate, and if we integrate, we will get what? We will get v. So here it will be the integral of negative t plus 1 dt. And then if we integrate that, we will get negative t squared all over 2 plus, what is the integral of 1 dt? Anyone?
T.
It is t.
T.
It's going to be t. Thank you so much. So, and then what else do we need to write there?
The constant.
The integration constant. So we'll have the c there, we have the v there. Okay, so now this is the general solution. Okay, it is the general solution because we still have this unknown constant. Okay, but then if we use this condition, it will help us to get the value for c. And then once we are in a position to get the value for c, we will no longer have a general solution, we will have a particular solution. Okay, so now let's use that. So what this is saying is that when t is equals to 2, v will be equals to 1. So where there's t, we will substitute that with 2, and then v we will substitute that with 1. So in this case, we have what? We have 1 is equals 2, so that'll be 2 squared there, so that we have negative 4 over 2 plus 2 plus c. Okay, so now let us simplify and solve for c. What is c? Let's look at the screen. Try to calculate the c for me. What is c?
It's 1.
It is 1. So now that we have the value for c, we go back to your general solution. Okay, and then you substitute the value for c. And then once you substitute the value for c, you will have what? The particular solution. So in this case, we have what? We have v is equals to negative t squared over 2 plus t plus 1. Okay, is t plus 1. So this is the particular solution of this differential equation. Okay, any question? Okay, if there are no questions, we will move on to the next exercise.